Okay, come. So today we're going to discuss alcohols and phenols. Right. I tell you how I split this topic first. Okay, generally, this how I split the topic, right, should be how you guys split the topic also. So that when you study that time, I would say it's a bit more structured. Okay, don't just whack everything at once. Okay, I feel really good. Okay, so first lesson, right? Today we discuss alcohols, everything. Phenols we'll touch on a bit before we end off the lesson. Okay, because next lesson is more crucial. Next week's lesson we'll discuss on acidity. Now, organic chemistry, right, got acidity concept. Because there's something called carboxylic acids, right? Okay, other than that, alcohols and phenols are also considered acidic. It's a whole new concept. That's why next lesson I'll spend quite a bit of time on this. But mostly it's tutorial lah. Okay, next lesson when we do tutorial, my focus is on elucidation. Okay, so you might have seen elucidation being taught already, but here we're going to properly teach it because now then we got enough reactions to do an elucidation question properly, not like the previous ones where there's not much reactions to test. Anyways, okay, for today, once we have covered alcohols and phenols, okay, I'll talk about it first. This topic, no mechanism. Now, some of you may say that's a good thing, okay, because you don't need to draw the arrows and whatnot, right? This topic has more reactions to compensate for that. Okay, but later on, right, I will also talk about a bit of mechanisms also. Okay, like I will give you guys a random exam question, right, and then we can just try. Okay, no choice lah, huh? Okay, anyways, okay, go over to like the second page, right? We're just going to do a very, very quick exercise before we start on the organic stuff. Once again, you need to know how to classify primary, secondary, and tertiary alcohols. By now, it should be a bit faster than compared, let's say, to 1 month ago. Okay, I'm going to draw 6 different compounds. Again, your job is to classify it into the correct boxes. Okay, in this chapter, it is important for you all to identify, because if not, later you will identify the wrong reactions. Okay, so primary, secondary, and tertiary, right, depends on the reaction type. Okay, anyways, here are all 6. 1, 2, 3, 4, 5. What am I missing? Okay, so here are all the 6 structures. It's very quickly classified already. Okay, at this point, some of you guys may not find it very difficult to do this now. Okay, so on page 3, they give you all the 3 boxes. Just fill it in. Okay. It's actually very good. Because usually, right, then dilute, then can't taste shit. By the time you taste the powder during your exercise. Wow. Okay. Okay, I'll just like quickly scan over 1, 2, 3, 4, 5, 6. Okay, nice. Careful, there's no ring here. I didn't draw a ring. Okay, just careful, I didn't draw rings for this and this. So don't anyhow draw rings there. Okay, generally not a very big problem here. Okay. Let's wait for the rest to finish up. Okay, nice. Okay. 2, 3, 4, 5, 6. Okay, good. Okay, so yeah, this exercise quite simple. That's good. The next page we discuss phenols. Okay, again, phenols I'll discuss in the later half of the lesson. Now take note, phenol is the entire thing, not just the OH. I think there's a confusion a lot of people have. Benzene and the OH, the whole thing is one unit phenol. Okay, so that's one functional group itself. So don't say that functional group is alcohol. No, Alright, the whole thing is called phenols. And is this a phenol right here? Is this a phenol? No, right? Okay, a OH must be bonded directly onto the benzene in order to consider it as a phenol. That is an alcohol still, so just be careful. Okay, then you can flip over to the next page. We have structure and bonding. Now, I'm not going to cover much on the structure and bonding portion. I said before, right? I'm not going to use this to discuss chem bonding. That one not really, okay, we don't really have time for that. Okay, in fact, on page 5, I'm just going to cover the first box and then we can move on. Right? So, first of all, perhaps just draw in this particular alcohol. We're just going to answer 2 questions and then we can start on organic. Okay, perhaps just answer, right? What is the structure and bonding of this compound? Okay, as for the rest, you can answer it on your own time because the moment you can identify structure and bonding, the rest is quite straightforward. So, what's the structure of this compound? In fact, most of our organic molecules, right, they are all simple molecular, right? Not much of a difference. But it is the bonding that I'm more concerned with because, guys, whenever there's simple molecular structure, how do we answer the bonding? Can we just say covalent bonds? No, for simple molecules, take note, I want you guys to specify the intermolecular forces. It's like your IDID, PD, and all that stuff. That is relevant, okay, not your covalent bonds. So perhaps if you stare at this molecule hard enough, right, what is the first interaction that comes to mind? Hydrogen bonds. Okay, very good. Okay, because we have a big OH group over there. O bonded to H, okay, you can form hydrogen bonds. Okay, please take note. Don't just say PD interactions. No. Here, this guy can form something better, so you must mention hydrogen bonds. But on the other hand, apart from this small little functional group, what else do we have? The rest of the molecule, right? Now, the rest of the molecule, what interactions? ID, good. Okay, so please acknowledge this. In a molecule, there could be more than one interaction. So don't just let it say OH, that's it. ID attractions, you must also specify, is due to the non-polar alkyl chain. So try to specify where and what has in whatever interaction. If you just say ID, the examiner can say, oh, but isn't this a polar molecule? Then you can't argue back already, right? So try to specify whatever. Any questions so far? Now, of course, after all this, right, okay, you can answer the questions yourself, solubility, melting points, all that, you just choose whatever interactions that are relevant in the question. Okay, can? Now, what we're going to do now is go over to page 8. Because, guys, I did brief you guys a little bit on how to do up your revision for your organic stuff, right, organic reactions. Just going to very quickly cover that once more. Now, remember, when you study organic chem, right, you're supposed to split it like this. Your functional groups are already split based on topic, right? So you don't have to do that. Okay, the topics already do that for you. But what's important, right, is to split it into 2 things. Synthesis followed by reactions. Now, guys, we're going to cover synthesis first. For every topic that you study, right, always look at synthesis because it's stuff that you have learned before. What do I mean? Now, remember, to synthesize an alcohol means how to make an alcohol. To make an alcohol, you need to know some previous knowledge. So that's why we're looking at previous topics. Reactions we'll cover later, in which we have alcohols reacting to form new stuff that we haven't touched on yet. So when you revise every topic, right, synthesis, you should spend only about 20% of your time. Reactions is 80% of your time. Okay? You cover synthesis first. And guys, this is what you need to do. On page 8, you notice a lot of space. We're going to use this space to cover all the synthesis parts. Now, guys, I don't want you to refer to the notes for this because the notes is just there for the sake of being there only. It is not useful for you to study. So what we're going to do is this. The first functional group that we need to consider is what? I mentioned your functional groups, you need to know the sequence, right? So what's the first one? What's the first ever functional group that we have learned? Alkanes. Now, alkanes, is there a way to form an alcohol from an alkane directly? No. Okay, and because of that, right, okay, we can skip over to the next topic. The next topic is alkenes. Guys, is there a way, right, to form alcohol from alkene? Answer is yes. So this is what you need to write. First, you write down the functional group alkenes. Okay, but the very first thing you must always write down is the reaction name. Guys, what's the name of the reaction when alkenes turn into alcohols? Okay, EA, right? Electrophilic addition, so that is number one. Type of reaction must be written first. Number two, you must give me the reagents and conditions. Now guys, at this point, I mentioned quite a few times, we are just after the halfway point for organic chem. It's just gonna get worse in terms of content, right? So you really need to start consolidating all this alkanes, alkenes, arenes, and all that. Okay, must begin already. Some of my students have already submitted their cheat sheet to me. Okay, where they fulfill all these things basically. Okay, anyways, reagents and conditions. You have again, this one if you can't remember, I can't really say much. Just need to go and revise again. Steam H3PO4 catalyst, high temperature and pressure. What I'm interested in, right, is the equation. You must graph an equation yourself, but it doesn't need to be balanced. Okay, if you can't balance it, right, at least have the main products in mind. The main compounds here are alkene. It reacts with water in order to form an alcohol. That's all you need to write. No, cannot say H2SO4. Okay, guys. This is the industrial method, if you remember. There's another method called the lab method. Now, the lab method, I'm not a fan of that reagent and condition. Because I see there's so many different variations. You add water, then you add concentrated H2SO4 and coal. Something along these lines. Because I'm not a fan of this because, right, number one, it's 2 steps. And number two, different schools, right, I see so much inconsistency in the notes. One school, I see they put concentrated H2SO4 warm. Then the other school, I see they put that cold. It's very odd. So I personally, right, have started to omit this from my reaction bank in my head already. I basically only use the industrial method from now on. That's my personal recommendation because that has remained consistent throughout all school notes. And you can pick anything you want. It doesn't matter what industrial or lab, it really doesn't matter. But what's important here, guys, does it matter where the OH goes? The OH can go onto this first, the middle one or the end, right? Does it matter? Yes, what's the rule called? Markovnikov's rule. Okay, now I'm not going to spend time going through Markovnikov's rule over here because clearly, right, that's an alkene thing. In your own revision, right, of course, you need to include Markovnikov's rule and the explanation. But remember, this is the major product because it forms the more stable carbocation. Okay, major product because it forms the more stable carbocation. That's essentially Markovnikov's rule. Not going to go too deep into detail, but guys, this is what you should roughly have in your revision. You write these 3 things off, don't just copy straight from the notes, and then you notice, right, I can talk about Markovnikov's rule next, and then that's when you can digress a little bit, go to the side, and then you start writing about Markovnikov's rule. Okay? Like for example, I tell you how you can study this, you can diverge to the side here, Markovnikov's rule. And then suddenly you say, right, this is the one carbocation, this is another carbocation. Then you compare and you write down the explanation. Something like that. Again, there's no set format for revising. It's just I'm telling you all this one can transition into another concept. Okay, anyways. Okay, let's look at the second one. Guys, after alkenes is done, what is the next reaction? Yours. Okay, guys, after alkenes, what do we have? Arenes, right? Okay, arenes is benzene, so benzene has nothing to do with this yet. We skip that. After arenes, what do we have? Most recent one. RX, right? Halogenal alkanes. Is there a way to form an alcohol from a halogenal alkane? Yes, what's that reaction called? Sub. What's that? Nuclear sub. Okay, good. Guys, I'm just gonna go over this part once and for all. How do you know? A few students have asked me this. How do you know whether it's electro or nuclear? Right? Now you must always look at the functional group. So come back to this. Alkenes is the functional group alkene rich or poor? Okay, having a double bond means you're rich, right? Okay, so if your alkene is rich, that means it must attack a what? Something that is poor. What's poor? Electrophiles. So it's called electrophilic act. On the other hand, you don't believe you try for this. Halogenyl alkanes, are they rich or poor? Perhaps I draw one particular structure. Is it rich or poor? If you remember the mechanisms, this is poor because of who exactly? The carbon bonded to the Cl. Very good. Okay, so if this guy is poor, it means it must be attacked by something that is rich. So we have nucleoside. So all in all, I repeat myself, just look at the nature of the functional group. Is the functional group rich or poor? The next chapter, we are going to look at one final version, something about nucleophilic something. Okay, but anyways, reagents and conditions is something that again is set in stone. Just use NaOH equals and heat, and more importantly, equation. Now, guys, sometimes the equation, if it's very easy, you just try your best to balance. But the harder ones I'll talk about later, they don't need to balance. Okay, but anyways, you have a halogenyl alkane, you add OH minus, and just perform a simple little swap. There's really not much for me to discuss. That's pretty much it. But again, right, in the actual, when you actually revise halogenyl alkanes, that topic, we need to talk about SM1 and SM2 afterwards. Okay, your revision. But now, if I'm revising the synthesis of alcohols, I just mentioned this and I'm done. Then you can move on to any other reactions. Okay, so far? Yes. Okay, so remember for NaOH equals and heat, the one that's very similar is ethanolic NaOH and heat. Now they look very similar, the only difference is the what? Aqueous and ethanol, what are they? They're acting as a solvent. Okay, it's what you dissolve NaOH in. If you dissolve NaOH in water, you will get a nucleosub reaction. If you dissolve NaOH in ethanol, you will get a, can you remember? Elimination reaction. That is the stark difference. Just one little solvent can change the course of the entire reaction rate. Okay, okay. And no, it doesn't produce alcohol. If you have, let's say, a halogenyl alkane, you undergo elimination, you must get rid of HX. So you get an alkene, HCl. Okay, so sometimes, right, okay, your train of thought will diverge because you'll be reminded of things that are similar. And that's fine. You can also include it in your revision. That is part of revision. Revision is when you keep thinking of random shit, right? That is slightly relevant to whatever you're going through. And that's like a digression, but you must come back lah. Okay, this is not relevant to this case because you don't form alcohols. So that's how you erase this and you come back on the track. Okay, next. We are done. That's all we have learned so far. So guys, the next two reactions are something that I haven't taught you guys yet. Okay, it's kind of like a reaction you learn in the future. But write down first, because the next topic we're going to discuss carbonyls. There is a way to form an alcohol from a carbonyl, and the reaction is called reduction. Now guys, your job over here right now is not to recognize the reaction yet. Your job right now, I just want you guys do me a favor, recognize how the functional group looks like. I'll be introducing new functional groups, which I'll discuss later on in the lesson also. But for now, recognize that an aldehyde is this guy over here. And aldehyde can reduce into a primary alcohol. Again, guys, don't worry too much about the reaction. We will touch on that eventually. Recognize how an aldehyde looks like first. That's what you should spend your time looking at now. And the next guy is called a ketone. I know all these names are very, very funky. But again, only recognize. Okay? Draw them out also, because if you don't draw them out, right, it's very hard for you to recognize also. I can say all I want and it doesn't matter. Okay, so as you start absorbing that information into your head, I will talk about what the reagents and conditions are. If you are undergoing reduction, obviously you must have a reducing agent. Do you all remember what that reducing agent that we have learned? It's a very new reducing agent. Looks a bit weird, right? It has like 3 different atoms in that compound. Can you remember what it is? Helium. No, KMNO4 is oxidizing agent, right? Now we're looking at a reducing agent. So the opposite of KMNO4, right, is this guy called lithium aluminium hydride. Okay, don't get this formula wrong because you need to write. Eventually you all will get it correct. You write so many times. Lithium aluminium hydride in dry ether. Write the whole package. It's the strongest reducing agent in our organic syllabus. If you blur, you remember this one, you write down high chance you get it correct already. Okay, but there are alternatives. Okay, so other than that guy, right, there's hydrogen in nickel catalyst at high temperature and pressure. This is the first reducing agent you have learned in alkenes, all the way back in alkenes. Both of them work in this scenario. But in the next chapter, then I will also introduce a third reducing agent called sodium borohydride in methanol. So if you want to reduce aldehydes or ketones, you can use any one of the three. But my personal suggestion is right now, try to absorb this, right? Okay, LiAlH4, dry ether. The rest, whatever lah, I'll talk about it soon, right? So maybe in the next chapter. All good so far. Okay. Now, there's a fourth version. Again, you have not learned this yet. Involves a topic, two topics from now, called carboxylic acids. Okay, carboxylic acids can also undergo reduction. And just recognize, I'm sure you all know how a carboxylic acid roughly looks like. Okay, it is C double bond O, OH, turning into a primary alcohol. Once again, write this down. So I'm aware, right, that all of them look very similar. All of them have a double bond O, but the difference clearly lies in the right-hand side, the tail end. Okay, and take note, for this reduction process, right, the reducing agent is only lithium aluminium hydride in dry ether. You cannot use any of the other two. Okay, maybe as soon as in the next topic, I will be telling you guys which functional groups these three reducing agents can reduce. Which you eventually need to know, but I usually last time I tell you all in the last topic, but now I think it's better if I tell you all as early on as possible. Okay, but anyways, yeah. Okay, again, just recognize the functional groups. Now we're just going to move on to the next page. Sorry, not next page. Okay, but anyways, whatever that you have done on page 8 is whatever you need to replicate. Everything on this whiteboard. You need to do this for basically every functional group, for every synthesis, for every reactor. Now let's move on to, I think, page 13. You can skip like a couple of pages by doing this. Right? Okay, I'm not saying that the notes are useless. It's just that I have to put it there, you know. If not, it's not called notes, right? Okay. Now turn over to page 13. This is where the meat of the topic starts. And this is where I'm going to be discussing the reactions. Now, any questions? Okay. Now, the first thing you'll be greeted with are 6 points. As I mentioned, there are no mechanisms in this chapter, so they compensate that with more reactions. Now, the 6 reactions here, I want you to list down the 6 reactions from my perspective. Okay, I want you guys to write this way because I feel that this is a bit better than what's labeled in the notes. Okay, not to say that the notes one is wrong, it's not. It's just that I feel that this way of remembering is better. The first reaction is actually redox. And beside that, I want you to write down acid-metal reaction. Reasons because whenever I say redox, everyone just has no idea what I'm referring to. So acid-metal is a lot more specific. Number 2, we'll be looking at condensation. I'll be spending quite a lot of time on this. Number 3, nucleosub. So far it's like around the same as the notes. Number 4, I need you to write this as dehydration. Now dehydration, right? The notes write then elimination. We have learned elimination, but I want you guys to now look at it as dehydration instead for this topic. I'll explain later. Let's write down first, right? What do you think dehydration means? Like legit, I'll take a smart guess over here. What is dehydration? What do you think I'm doing here? Yeah, you're just removing. Dehydrate. Remove water. Yeah. That's literally it. The reason why I introduced this term, okay, it's not like a term that's not in the syllabus. It's just that it's a lot easier to study. Anyways, number 5 is oxidation. Yes, written. But for number 6, I need you all to write this down called iodoform test. It's a very important reaction. It's not that it's not covered in the notes. Iodoform test is a subset of oxidation. And because of that, it is technically considered oxidation. But because it's such a novel and new reaction, right, I will split it into ionoform test itself. The reason why I want you to come out with this 6, right, is because that is how I personally advise you guys to study. I don't want you all to think of it as 6 reactions. I want you to think of it as you assign a particular value to a particular reaction. So how I remember all these reactions is I numbered them. So for me, right, if you ask me what's reaction number 5, I can tell you straight away it's oxidation. You should come up with something along the similar lines as this. You don't want numbers, you want to put alphabets, it's up to you. As long as you assign a value to the list, right, I feel that this is very good in your revision. Okay, Ken? Anyways, I skipped one reaction called combustion. Yeah. The reason why is because it's not that important. And now I want you guys, right, to find some empty space and then just do this thing for me. I want you all to write down a balanced equation for the combustion of an alcohol. Okay. The reason why we're doing this is because eventually you need to do it anyway, so might as well do it in class. Okay. It's in the notes, but you can't just stare at it because you really need to try this yourself. The important thing is I need you all to come out with state symbols as well as you're writing down the equation. These state symbols at room temperature lah. The alcohol I want you all to use is CXHYOH. Assume it's complete combustion. Go and come up with the equation first, and I need you all to balance. Okay. Okay, try not to refer to the notes. Again, everything is there. I know the answer is there. But no point if you don't know how to balance yourself. Okay, the coefficients must still use x and y. No choice. Because you don't know what x and y are. Okay, but anyways, okay, we can roughly gauge the products and the reactants. Okay, so if you add oxygen, you should get carbon dioxide and water. State symbols, okay, alcohol, you should make a smart guess. Alcohols at room temperature are clearly liquid state. Okay, oxygen gas, carbon dioxide gas. Okay, remember, water is a liquid at room temperature. A lot of people write it as a gas because you all think combustion makes it very hot. No, no such thing. Okay, now take a look. What's the first element to balance? Okay, carbon. Carbon only, okay, you should always have a rule of thumb. Balance atoms or elements that appear only once. Carbon only appears here, X carbon, so this X carbon dioxide, as simple as it can. Okay. How about the next thing? What should I balance next? Always H, because H also appears only in one compound. What's the coefficient? Okay, good. Y plus 1 over 2. Don't forget, there's another H over here. Now, the hardest one to balance is oxygen. Please do not use I power to balance this. It's not going to work out. Okay, just write down your working. In this case, you must know that the right-hand side oxygen and the left-hand side oxygen must be equal. So how many oxygens do I have on the right? 2x, right? Plus y plus 1 over 2. Can you see that? That means over here, you must also have 2x plus y over 1 over 2. Then what do I do next? Just divide by 2, right? Okay, but don't forget, there's another O over here. So to find the coefficient of this, I need you to minus 1 first, then you divide the whole thing by 2. To simplify, you can simplify the whole thing, now a bit ugly. So it's y minus 1 over 4 plus x. That's the answer. It's a bit tricky, because one of the tutorial questions, right, which I will assign to you guys as homework, because you probably will have time the next lesson to cover this. It requires you to balance this equation like so. Okay, if you can't balance this equation, what you're going to do, you're going to end up referring to the notes, and then you're just going to copy straight. But are you really learning in that case? No. Okay, so any questions here? Practice one more time, yes. Okay, because over here it was 2x plus y plus 1 over 2. It's how much oxygen there is on the right hand side, right? Now, the oxygens on the right and the left must be the same. So, but I must minus 1 because there's an oxygen over here. You can see that. So, what's the coefficient of this? Because there's a 2, I need to divide by 2. 2x divided by 2 is x. Y plus 1 over 2 is y plus 1 over 4 minus half. Then you can simplify this times 2 here, times 2. So it's x plus y plus 1 minus 2 over 4. Then you can get 1 minus 2 give you minus 1. It's just all simplification. Again, if you don't want to simplify, right, it's really up to you. You want to leave it like that also can. Okay, this is not math. This is chem, so they don't give a shit. Okay, it just looks a bit ugly to me, so I like to simplify it. Yeah. Okay, so your working should always do in pencil, then you can just erase afterwards. Then very nice. So again, those who got this wrong, try yourself. We go. Actually, eventually, I'll just give you all the question that you do. Okay. Any questions so far? No. Okay. So with that said, I'm done with combustion already. Okay, just turn over to the next page. Sorry, we're gonna start on the first reaction now. Redox. Okay, for redox, they also call it acid metal because I want you all to recognize it as acid metal. It's a lot easier. You take an alcohol. You react with sodium, you can get yourself your salt plus what? You all learned this in secondary school. Acid plus metal must produce what? Hydrogen gas. Yeah, okay, it's the same thing over here. Okay, but I want you to highlight one thing. Highlight the hydrogen gas because it is half a mole. Reason being, because you only take out one H from here, right? So one H is just half a hydrogen gas. Now that's literally it for this reaction, I know. But I'm going to introduce how they would purposely, right, test you on the half a hydrogen gas concept. Because if you can't get this right, okay, it's a little bit wasted. Okay, what I want you all to refer is this. I mentioned structural elucidation. Now, in a structural elucidation question, they will give you a bunch of reactions, and your job is like a detective. You are meant to deduce all the reactions to eventually arrive at the unknown compound. So how would a sentence look like? So they call it observations. Basically, it's a reaction in the question. So perhaps you can copy down this sentence. Okay, I have this random compound called compound X. 1 mole of compound X reacts with excess sodium, okay, to produce 1 mole of hydrogen gas. This is an example, right, of a sentence that you would see in a structural elucidation question. So this is like a little transition before I get there eventually. But anyways, once this is out, then you must give me your deduction, right? You are basically a detective here. You must tell me what that means. And to earn 1 deduction mark, I need you all to write down 2 things. A, I need you all to write down the type of reaction. What the hell is this reaction that happened? Is it electrophilic addition, nucleosub, or whatever? Must write it down. Okay, then afterwards, the important part is what's the functional group? The functional group present in this compound. Okay. Perhaps I'll give you guys maybe a minute or less. Just think about it. Maybe you want to fill out the first part. Second part, you don't know how to fill in that part. Okay, at least tell me what reactions happen. Nope. This is done on purpose. So that's why I need you to tell me what this means. Okay. This is not a typo, huh? It's 1 mole of hydrogen. Think about what this means. You already spot the slide. You already spot what's interesting in this question already. Okay, so let's answer this together. Guys, what's the type of reaction? What will you fill in the blanks over here with? Okay, what's the reaction here called? Okay, because we never really learned much, right? We are just talking about this. So this is just an acid metal reaction, right? Okay, X reacts with sodium to produce hydrogen. We can only infer this is an acid metal reaction. You tell me redox also can. But I'm more interested in the functional group. Guys, what functional group is present in the unknown compound X? What does it have? What does it have in order to react with sodium to produce hydrogen gas? It must have, no, not water. Okay. It must have an alcohol functional group, right? Because an alcohol can react with sodium to produce H2. Okay, but that's not enough. Okay, because they also specify the amount of each species used. What does this mean? 1 mole of this unknown compound can produce 1 mole of hydrogen. But we know for a fact 1 OH only produces half a hydrogen. What does this mean? No, nothing to do with equals. Okay, see again now, guys. Compound X has an alcohol functional group. It's alcohol, yes. But you see, right? 1 mole of X produces 1 mole of H2. But we learned 1 alcohol produces only half a H2. Exactly, that's the answer. You can see, right? Okay. Compound X has 2 OH groups. It's also known as a diol. You can even tell me compound X is a diol. It's because this one guy has 2 OH groups. That's why you get 1 mole of hydrogen gas. The reason why I'm writing this out now is because this sentence looks very innocent. 1 mole, everyone will assume everything is 1, 1, 1, 1, 1. No, that's not the case over here because you can see half a hydrogen. This is very commonly tested in an elucidation question. Okay, this is how you spot it, of course, takes time. Okay, anyways, to kind of complete this, can you give me an equation here? Okay, I know you all don't really know how compound X really looks like. Okay, but just anyhow draw a compound X that has 2 OHs, right? In the real exam, in the real question, they'll tell you how many carbons, how many this, how many that. It's more specific. Now just give me a diol. You react with your sodium to give me your whatever. Go and fill everything up, basically. Okay, practice your equation drawing. It creates some random structure. I don't care how it looks like. It'll be wacky as hell. Just make sure you got 2 OH already. Yeah. Okay, I can draw any random looking thing. Okay, I'm just gonna draw like this. So draw simple 2 carbons and 2 OHs. You put on the different carbons also okay. But just make sure when you balance that time, you get O minus Na plus for both of them. And finally, only 1 mole of hydrogen gas, as mentioned in the question. Okay, but remember to balance everything, which means I need to see 2 Na over here as well. Okay, 2 sodium. So far, any questions? Okay, can? Good. Right. So this done. We wait for the comeback before we start on the next part. Okay, anything you want to ask? Okay, you can just ask me now. Or do you all get back your A level Chinese, or wait, what, do you have any? Oh, you also take it. Okay, how was it? Got at least the requirements what pass? Yeah, got pass right? Yeah. Okay, good. Can as long as above, no need take again, can already. That's good. You get back. How was it? Can. Okay, as long as you all don't take again, good. You don't want to waste time taking Chinese. Whatever stupid mother tongue. It's damn stupid, waste of time. We do it for you so stupid. Use that as an energy booster. Oh, it's damn good, yeah. Go and munch the piece off. Yeah. That was an Oreo also, Oreo beats. No way now, buy it. Buy it expensive. Oh. Where you get that from? Oh, yeah, they have a store there, right? Shows us. Really damn hot. Okay, anyways, okay, we can now start on condensation. Alright, yeah, I'll spend quite a big deal on this condensation. It's a rather unique reaction. So let me tell you what condensation is in informal terms. Okay, you might want to write this down also. Two small molecules combine into one large molecule. Okay, settle first. Two small combine into one big. But the catch is you form a small byproduct. Okay, now I mentioned this because there are some MCQ questions that ask you, what is this reaction? Addition, elimination, condensation, oxidation, something like that. To identify, you just need to look at two molecules combining together. But again, the catch is that you have a byproduct. So I'm going to use the example in this topic to discuss what condensation looks like. The most classic condensation example is this, and I know that's in the notes, but again, that's not in skeletal. So please draw the skeletal version. I have purposely used two different carbons. Okay, in other words, my alcohol has two carbons, carboxylic acid has three carbons, so you all can see which is which. Okay, so take note, alcohol, carboxylic acid, very, very nice pair. Will form this new functional group here called an ester. Okay, this is an ester, but main thing is that you form a small byproduct called water. So guys, just take a look, right? Two small molecules combine to form one big molecule. Can you see that? But at the same time, you shit out a small byproduct called water. The main thing is to know, right? How do you form the water? Okay, so you see, right? Water, I tell you all first, later we'll see why. It comes from the hydrogen in alcohol and OH in carboxylic acid. Okay, alcohol contributes the H, carboxylic acid contributes the OH. Some of you may be asking me, why can't it be the other way around? Can it be alcohol contribute OH and carboxylic acid contribute H? Does that give you water still? It does, right? Yeah, but you just can't do it. Okay? It gives you water by doing the opposite, but it's not part of the process. Later we'll see how it works. So just going to take note. Remove the H from the alcohol. Then you remove OH from carboxylic acid. Bear this in mind. Okay, so I want you all to circle out all these things also, right? Okay, so it's easier for you all to see. If you don't circle out anything, if your equation is too clean, then clearly there's a problem. So just going to stare. Okay, this is how an ester looks like. Okay, C double bond O, and then it's all alkyl groups on both sides. It just know the difference between that versus a carboxylic acid. As you can see, this reaction kind of sucks because it's a reversible arrow, correct? How will you make the reaction better? Okay, the reaction is reversible and it's slow as hell. What can you do? Logically, what will you add? A catalyst, yeah. Okay, so the catalyst in this case is a few drops. The few drops is important. Few drops of concentrated H2SO4 and you heat it. Why you heat? Because it's already damn slow, right? We learned in kinetics that heating reactions makes them faster. Hey guys, catalysts are can you add a lot? Can you whack a lot of catalysts inside? No, catalyst is usually in small amounts. That's why it's only a few drops. You see that? Yeah. Later we will understand a little bit more about what the H2SO4 does. But as of now, right, let's just discuss the other reaction. There's another equation over here. We might as well just cover it first. Okay, go write down again. Now you all notice the problem with this reaction is that it takes a few hours and it's slow as hell. It's not even that complete anyway as well, right? So there's actually an alternative. I can take an alcohol, react with this new functional group called acyl chloride, and I can still form my ester functional group. But this time around, what do you think the byproduct is? The byproduct here is clearly H from alcohol, Cl from acyl chloride. This forms my HCl. It's also a small byproduct, so it's still fine. And more importantly, I can still get back my ester. Okay? Not H2. It's HCl. Let's infer a few things from this reaction. Guys, for one, right, you can already see the arrow is different, right? The arrow is now a full arrow. Guys, what does this tell you about acyl chloride? Okay, I repeat the question. I swap out carboxylic acid for acyl chloride and suddenly the reaction is very, very good. So who's more reactive? Acyl chloride is correct. Okay, that's the answer. So in this case, perhaps you want to write down at the side, acyl chlorides, for your own information, are the most reactive functional group in our syllabus. Now, it's not the most reactive in real life, no such thing. There's a lot of funky ass nonsense out there. But for now, you just need to know within our small little syllabus, right? Okay, it's acyl chloride most reactive. Okay? And guys, because it's so reactive, do you think I need to heat the reaction? No. In fact, this one is so good, your room temperature can settle already. So imagine you want to conduct this experiment, right? Which route will you go for? Clearly the second route, right? Because you don't need to set up so many things. You don't need to add catalyst. You don't need to stay there. You don't need to sit there for 4 hours. Okay, this one can do in such a much shorter period of time. So this right here is condensation. 2 small molecules become 1 big molecule and they shit out a little byproduct. Any questions so far? Look at how the reaction is done. Now we ask ourselves, what is the purpose of con H2SO4? Now guys, at the bottom of this page, we get this done and over with. Concentrated H2SO4, they mentioned that it has 2 functions. Number 1, catalyst, we know that. But number 2, dehydrating agent. Guys, you have to make a guess on what a dehydrating agent does. What does it do? Very clearly, a dehydrating agent must remove water, right? Okay, you refer to the first reaction. What's the benefit of removing water? Okay, there has to be a benefit from this, right? Guys, look at the equation. It's reversible, correct? So if I remove water, what's going to happen? The position of equilibrium now shifts right. And when you shift to the right, what are you achieving? You're producing more of the thing that you want, right? Your ester. That's it. Okay, so in the box over there, it's very simple. Very fast explanation. When water is removed, the POE shifts right, which increases the what of the ester. Guys, what's the word over here? when you describe the amount of your product, what's the word that we use? It's like Y. You remember? Your yield. So what I want you to add in is this also. Catalyst is to address the rate problem. Dehydrating agent is to address the yield problem. Take note, they are different things. A lot of people conflate rate and yield. It's different. Rate is like slow and fast kinetics. Yield is the extent of the reaction. This reaction is not very complete. You are trying to make it more complete by forcing the position of equilibrium to the right. Both factors come together is a very good way of making the reaction a lot better. And okay, now this part very simple. They won't really test the explanation for this. You all just need to know why. So I'm just going to erase this part. Now, before we move on to the next reaction, let's draw a mechanism. Okay, exam style question. Okay. Now again, I know they never teach you all the mechanism for this. Okay, but they can still give you they can still test this in an exam. How? Now, I want you all to find some empty space. It may not be on this page, so you might want to flip over to like the final page or the first page of the notes where there's empty space. And then just write there like refer to this page, refer to that page. Okay, then make sure you don't forget about it. What I want you all to do is to copy down the instructions for this question. Then afterwards, I tell you all what you all can try doing. Again, the reason why we're doing this is because exam like test all this kind of stuff. You never learn in the notes, but then they can tell you to draw it out. Yeah, okay. It's becoming quite common now. What I just written on the board are the instructions to the mechanism. Your job is to follow the instructions carefully and try to draw all the curly arrows, the partial charges, and any lone pairs of electrons. That's what exam question will ask you to do also. Include these three things. If any one of them is missing, that means your mechanism probably missing something. It's probably wrong. I want you to try a little bit. Okay. Again, I don't expect you all to know how to do this question perfectly because it's not easy at this stage. Okay, just try a bit, then later I'll just go through it. Again, like just follow whatever the instructions tell you. If the instructions never say, don't do. Okay. Okay, come. We'll talk about this now. Okay, I just again don't need complete. Just want you all to roughly try only. Okay, but anyways, every time you all do a question like this, right? There's always a very nice structure to it. Okay, so it's not like you are thrown into the wild for you all to go and do whatever. Okay, so come, let's take a look. Now, the very first thing to draw is obviously the reactants, right? Okay, I'm referring to this first reaction here very quick, very obviously. Draw out the reactants first. Because obviously that's what you're starting with. Okay. Alcohol carboxylic acid. Okay, the first sentence says that alcohol acts as a nucleophile. Your job is to ask yourself what part about the alcohol makes it a nucleophile. Where? There has to be a specific part, alright? Remember, arrow movements in organic chemistry. Arrow point from what to what? Ah, good. Okay, always from rich to poor. That's like the most fundamental mechanism rule. Next, you must identify what part about the alcohol makes it rich. Okay, so what part about alcohol? Which part? Oxygen, why? Can you just point from oxygen? No, right? Remember, arrows represent the movement of electrons. I need to see you originating the arrow from a lone pair. The lone pair is the reason why it's rich. A lot of mistakes are because, right, you point from the O. Where are the electrons? Okay, you must show me first. And it attacks the electron deficient carbon atom of carboxylic acid. Which carbon atom are we talking about? There are like 3 carbon atoms there, right? But the carbon atom that we are concerned with is the one that's bonded to all the O's, right? Because O is more electronegative than C. Correct? So because of that, you must also tell me why the carbon is poor. If not, the examiner don't know why you attack that guy, right? It's electron deficient because it has a partial positive charge. So just go from rich to poor. Rich to poor like this. And that's 1/2 of the thing done already. Guys, but you continue, the CO single bond of the carboxylic acid breaks. I'm sure you all know which bond they're referring to. Now, even if they don't specify, right, I'm pretty sure y'all can tell, but I just specify for y'all first. Okay, what's the CO bond? It's only this guy here, right? Now, the bond break already, then go where? The electrons are going to O is more electronegative, so it takes the electrons here. So I need to see the electrons going from the bond to O. That's how it breaks. Can see that so far. So this right here is the first step. And those are all your arrows. See, they can ask you to draw this, but is it difficult? I really don't think so because they gave you the instructions very clearly. Now you form an intermediate. Let's see how this intermediate looks like. Okay, the drawing may be a little bit tough. Okay, I'll do it with you guys. Okay, take a look. Okay, what does this guy become? This OH break already becomes OH minus, not OH plus, okay, OH minus. Now, how do we know that? Remember the second rule of organic mechanisms, The second rule is, if you gain electrons, you have a what charge? Minus charge. If you lose electrons, then you overall have a positive charge. Use that thing over here. Okay, y'all notice, this oxygen here has gained an electron. Gaining means become OH minus. Okay, great. But can you draw the next guy? This one you need to visualize a bit. Okay, can you all see when this bond breaks, you can cover this whole part? We draw that part first. Alright. I just draw the right hand side here, which has nothing happening. The OH become OH minus out already. But guys, what is now attached to that carbon? This carbon is now attached to this whole alcohol, right? So it's bonded to the O. Bond this carbon to the O. That O still has an alkyl group with with a H. Can see that? The H is not gone. Don't anyhow remove the H. The instructions got say the H gone or not? No, so don't do anything with the H. Now guys, take a look. That oxygen over here must have what? Positive. How do you all know that? Okay, I know there's 3 bonds. Okay, but the more appropriate way is this. Follow the rules. This particular oxygen, what happened? This oxygen has lost electrons. Gave it away, so it must have a plus charge. You see that? Okay, so that's that. Plus minus still will neutralize the reaction. So far, so good. You only practice this mechanism yourself. Copy down this same question when you revise and try to do the question once again. But anyways, okay, let's come to our final step. Second step. Now, if you're aware that the second step is the final step, then what should you do? What should you write at the end of the day? The final products. Go and draw in your final products first. Okay, why I recommend to do this is because you can clearly see what is the difference between before and after. You look, just look. The difference is not much. So perhaps, right, can you all tell me what does deprotonated mean? What does proton mean? Proton is H plus. Guys, take note, proton and H plus are the same thing. Because you can list down all the subatomic particles for H plus, you only have one proton, so it's a proton. Deprotonate means what then? Remove H plus. Go write that down. What's the opposite of deprotonate? Opposite of deprotonate is protonate, literally, and is what do you do? You add H plus. Now these are terms, right? I'm not trying to make your life difficult. The school is making your life difficult. Okay, don't blame me. Okay, this one, right? I'm just telling you all what to expect. You will definitely see those words very soon. Okay, where do you remove the H plus? They don't have the same mark. You really can tell, right? Once you draw the final products, where's the H plus getting removed from? Clearly, is this guy, right? This guy needs to go. Who is to claim this guy? Someone must claim him. Who? OH minus. That's how he can steal the H to become water. So, okay, where the arrow attack from where to where? H to OH or OH to H? OH to H because H to poor. So I need to reduce the lone pair. Okay, if I don't see a lone pair, they're just gonna minus 1 fat mark away from your question. Yeah, I don't want that to happen. Okay, come, OH minus attack H. That's how water is formed, right? He lost the electron, gaining a positive charge. Positive plus negative go back to neutral. Can see that? Okay, after the H gone, then what happened to these electrons? Are just sitting here. Give to O. O is saying that it's full. I want the electrons. Give it to him lah. That's how it becomes neutral again. Gain electrons, he has a negative. Negative, positive, go back to neutral. Everything is now settled. That's how a mechanism will look like. This is how they apply mechanisms in exam. They will, okay, sometimes I know they will ask you, draw a nucleosub SN2 reaction. That one I teach you already. Just draw. But here, I know you're not expected to know this, but they can give you instructions. They can guide you through one. This is what you can expect in an exam, and you must do this again. Okay, this is not enough. Please don't forget about this. Okay, go back and try this again. Tutorial, I'll give you more questions that are similar to this nature. Okay, any questions so far? All good? Can and with that said, we will go over 2 more very fast reactions, and then we will take a short break. Okay, nucleosub dehydration is really not much. Any final questions here? Mechanism drawing. Okay, come, let's move on. Okay, good. Let's talk about what's this? Nucleosub. That was super easy. Why is it easy? Because there's no mechanism. But when I say there's no mechanism, don't take it too seriously, because sometimes they can really come out one mechanism for you guys. You must follow the instruction until you can get the answer. Okay, so anyways, nucleosub, how is this done? It's very simple. You can take your alcohol, substitute a halogen like Cl. You can substitute Br. You can substitute iodine. Now, is my equation balanced? I think anyone can tell me it is not balanced. And the reason for that is because it doesn't actually matter that much. You can see just one stare at page 16, you can already see there's so many things to balance, right? They don't really test this. It's not that important. If it's important, I'll tell you all. Okay. Reagents and conditions are what I'm concerned with. Now to look at the first one, the first one got a few. PCl3 heat. You can also use PCl5 at room temperature. or SOCl2 and heat. Okay, I know there are three, right? But you don't have to memorize all three. What I want you all to do, pick a favorite. My personal favorite that I advise you all to use is this, the most common one. Okay, you pick a favorite, but you must recognize all three. Don't pick a favorite and forget about the other two. You can't do that because, guys, in the example, if they print SOCl2 and heat, then you'll be like, what the hell is that? Cannot. Okay, so you must recognize it at least. Okay? Like whatever you want to use, right? When they ask you to write the ratio and condition, I will just write the one in the middle. Okay, can? And it goes without saying, for if you want BR, right, just use PBr3 and heat. I know the notes got a lot of random ass nonsense, right? I really don't bother about that. That one I never see much. You want iodine, then just put Pi3 and heat lah. It's only have like one each. Finish. But wait, some of y'all may ask me one question already. Why is there no PBr5? Yes, there's no such thing as PBr5. There's no such thing as Pi5. But there is such thing as PCl5. Let's just understand why. Any guesses? Okay, good. Guys, you see first, PCl5. You are surrounding one little poor ass phosphorus with 5 chlorine atoms, like 5 big burly dudes surrounding a little boy. So why does PBr5 and Pi5 not exist? Okay, why? Bromine and iodine. What's so different about them than chlorine? Okay, bromine and iodine are bigger, right? If they are bigger, do you think they can surround 5 of them around one atom? No, not possible. If having too many big items, too many bulky items, what's that concept called? Too many bulky atoms. There's a lot of, what's that concept? Steric hindrance. Can see that? Okay, so the idea is this one is like 5 teenage boys surrounding one little kid, but then the bromine and iodine are like bodybuilders surrounding a phosphorus. That one really you cannot fit, it's too big already. In other words, okay, the answer is very simple. Bromine and iodine are way larger than chlorine. And because of that, there's large amounts of steric hindrance. It's large enough, right, to make the compound super unstable and just not exist in the first place. Okay? Again, this one, I used to tell people just memorize, then that's it. Like that only. Don't write it. Okay, but a lot of people end up writing anyway. That's because you all don't know why. This what I tell you. Okay? Okay, I know the notes will write all the possible answers. Okay, again, not necessary. This is what you need. Any questions? We're going to move on to dehydration and then we'll take a break. Yes. Is there SOBR2? Is there such a thing? It's not there, so I guess it doesn't exist. Maybe SOBR2 is not practical. That's why it's not there. Like maybe it's like you burn immediately, real like that kind of thing. There's a lot of considerations. Sometimes if it's not there, it's probably because practically wise, it's not practical. Like maybe it's very hard to handle. So we opt for better options. Yeah, for some reason the CL has so many options, but BR and iodine not much options. Again, I also don't know why it doesn't matter. Yeah, if I say it doesn't matter, means it doesn't matter. Because I never see them as this level. Okay, can? Very quickly, let's go over dehydration. Okay, again, right? You all don't even need to refer to anything in the notes, right? And you can already tell me what dehydration does. Again, dehydration means what? Okay, you get rid of water. Right, okay, so I mean, very easy. Your school notes may not have this, so I just tell you all just in case. They might use the word elimination, not that it's wrong, because you're still getting rid of something. Elimination, bottom line is you are removing stuff. But now, I want to very, very quickly, right, okay, tell you all what's the difference between dehydration and elimination. Dehydration obviously means you get rid of water. You can't get rid of anything else. So I want you all to think of it as two separate ideas. Elimination, can you remember what you get rid of? Can you remember? No, it's easy, right? You can't think of something like water, right? Okay, that's why I say, right, must use that one for easier studying. Okay, elimination, get rid of HX. Please remember this from now on. Now, elimination can also get rid of water, I know. But then later you're confused here, confused there. Okay, so treat it as two separate ideas. Okay, we talk about dehydration today. Okay, why dehydration? Because very clearly, I have my alcohol, then you eliminate into this. I don't have to discuss much. It's the same process as elimination. I'm just going to quickly touch on the reagents and conditions. It's one of those scenarios where you see multiple possibilities, but I explain a little bit. Okay, guys, over here, excess concentrated H2SO4 and heat. Now, guys, earlier, when I talk about condensation, you all remember, con H2SO4, what does it do? It was a catalyst and a dehydrating agent, right? But obviously, so dehydrating agent, that means I use in dehydration, right? Everyone knows that. But you notice, just now, how much H2SO4 did I use? Excess, is it excess? No, it was just a few drops, right? Let's take note. Over there, you wanted it to act as a catalyst also. Catalyst, you cannot add a lot. If not, it will interfere with the entire reaction, to screw up everything. Okay? Over here, you want to literally just remove water. You don't need to speed anything up. So you just put it in excess. There are other possibilities. This is like the fan favorite. Okay, so just use this. Sometimes we will see concentrated H3PO4 and heat. I don't think it's very common, honestly. Okay, so if you forget about this, okay, but the other one which I see very commonly used is Al2O3 and heat. Please remember this as well. I feel like this one you write less anyway, so it's like I personally like this because it's very fast. Very commonly typed in the exam also. So first and last one, please recognize. So second one also recognize but it's not important compared to the other two. Okay, I never asked you to forget any one of them because the moment they come up one con H3PO4, they blur already. Okay, so we're gonna do a short little exercise under Z's rule. Then we can take a short break afterwards. I want you guys to dehydrate this guy. Draw all the possible organic products. Okay, I repeat my instructions. Draw the organic products only. How many are there? I don't know. You're going to try it. Okay. Oh, okay. That one I'll touch on it under oxidation again. But heat and heat under reflux refers to the same thing. Yeah, but usually I write heat, I get away. It's usually accepted. But I know some particular teachers, right? They're like, oh, must write heat under reflux, then no choice. Like the teacher's one of them, then just write the whole thing. Later I'll discuss heat under reflux. Okay, I see some of you have drawn only 2 products. There are actually 3 products. We've done this exercise in halogen derivatives. You all remember how elimination or dehydration works? You want to remove, must remove OH, but must also remove a H, right? Where's the H? Where do you remove from? Can it be from the same carbon? No. Must be always, you must check the guy beside. Does the guy on the right here have a hydrogen? Have, right? So you remove already, you will get this product. Is that it? We can also go on the left, right? Is there a H on the left? Have. So because there's a H on the left, you can also get this. However, there is a third product, and it's not water because I said organic products. Water is not an organic product. It's the cis isomer of this guy. So we label this the trans, this is the cis. So what's next? Now we need to discuss out of the three, right? Who's the best? Like who's the most likely to form? Who is the major product? Now I've discussed Césare's rule before. It's not that important of a rule, but I'm just going to mention again. Césare, this dude, he says that the more alkyl groups there are on the double bond, the better. Again, you don't even know the actual definition because they really don't test the explanation for Césare's rule. You just need to see only. Guys, based on this rule, who is the worst? The first one. How many alkyl groups are there on the first guy? Okay, just one, right? Why one? Because you see, the double bond is here, but you only have one alkyl group. Notice how I use the word alkyl group and not the word carbon. Because these two carbons, but it's just one group together. Make sense? How many alkyl groups are there on the other two guys? Two. Already makes them better than the first one. Eh? One alkyl group on the double bond, two. 1, 2. But that's not satisfactory. Between cis and trans, they want to find out, okay, they always like to get to the bottom of this. Who is more likely to form? Cis or trans? Okay, why trans? Okay, good. We discussed the idea before, right? Okay, but before you all tell me about steric hindrance and all that, will you explain slowly first? Trans is better because why first? Why before it has less steric hindrance? The alkyl groups are on opposite ends, right? Now, opposite ends of the double bond means they have more space to breathe. So, alkyl groups are on opposite ends of the double bond, and hence it has less steric hindrance compared to the cis isomer. Can you see that? Okay, all good. Very easy idea. If they ask you to suggest why the trans has a higher proportion in the mixture, you already know what they are trying to test, right? Basically. Okay. Any questions so far? Okay, we take a short break before we continue with oxidation. That was kind of a hefty segment, right? Then later I'll touch a little bit on phenols. Okay, let's take a short break first, right? Okay, come. Let's continue to the next one. Okay, now we're gonna look at oxidation. Okay, the TikTok you're going to slowly go and watch. Wow, very embarrassing, honestly. Okay, anyways, for oxidation, this is quite interesting because, right, I need you all to first understand what's the criteria for oxidation. The carbon atom must have at least one hydrogen. Okay, take note of this first. The carbon atom must have one H in order to oxidize. If not, cannot oxidize. Okay? So anyways, you'll see for this example, a primary alcohol, we are looking at the carbon obviously bonded to the functional group. Does it have a H? Have, right? Okay, so it can oxidize. But you look at the same carbon, which is this dude over here. Does he still have a H? Yes, and aldehyde still has a H. So there's another stage of oxidation, oxidize to the final one. So from 1O become 2O. Now, does he have any more H? No, that's why it stops over here. It's quite interesting here, right? Because we have two stages of oxidation. The first stage and the second stage. For the first stage, right? It's the most important one because I need to control the oxidation. So I'm going to call the first stage, right? Control oxidation of the primary alcohol. Now guys, why do I need to control it? If I don't control it, what will happen? It will just proceed to the next stage, right? Obviously. So if I want to get an aldehyde, I must be very measured and very precise with my actions. In other words, we're going to understand how on earth are we going to control the oxidation? So take note, right? This is very important. The reagents and conditions is very specific. I need to use potassium dichromate as an oxidizing agent. H2SO4 is an acidic medium, that one no diff. But the catch that you will see is that you need to heat with immediate distillation. What this means is that once you heat already, once you get the aldehyde, you must immediately distill it away from the mixture. So let's understand why. Let's explain why this is a very specific step. Guys, K2Cr2O7. They say you can only use dichromate, you cannot use KMnO4. What does this mean? Okay, it is this guy's weaker, right? It implies KMnO4 is a way stronger oxidizing agent. If you use KMnO4, what will happen then? No matter what you do, you're just going to jump straight to the final step. You can't get aldehydes. In other words, when I write this down, KMnO4 cannot use as it is a stronger oxidizing agent than dichromate. Dichromate is a bit weaker, so it allows you to control the oxidation. Doesn't allow it to like go no chill, go to the end. Okay, Ken? That one's simple. But what I really want to discuss, right, is this statement here. Why do you need to distill it immediately? Okay, think about that. Why do we need to distill it? Okay, so perhaps before we answer all those questions, right? I hope you all remember what distillation is. We never really thought about it in JC, right? But secondary school you all learned before. Hey guys, what's distillation? It is what kind of technique? Separation technique, very good. Okay guys, how does it separate items? What property? The difference in boiling points. Compounds with different boiling points allow you to boil separately, right? Guys, let's first understand why do you heat with immediate distillation? As I've already repeated myself, is to distill the aldehyde away from the mixture so it does not turn into something you don't want, which is carboxylic acid. Okay, but think about it. I distill the aldehyde away from the mixture. What is in the mixture? What are they referring to? Okay, there are only three possible things here. What's in the mixture? Any idea? Alcohol. Okay, guys, is that carboxylic acid? No lah. Because I obviously am doing all this to avoid carboxylic acid. So the mixture is the initial starting reagent, my primary alcohol. I'm trying to get aldehyde to screw off from the alcohols so that he doesn't turn further into other stuff. But the question is, why are we able to do this? Guys, if I can distill aldehyde away from the alcohol, what does that mean? Remember, distillation uses different boiling points, right? That means aldehyde has a boiling point that is lower than alcohol. Lower means it will boil first. That's why you can separate it. You can screw off. So, go and write this down. From here, we can see that the boiling point of an aldehyde is less than the boiling point of an alcohol. Now, of course, now I can just simply ask you guys why. Why does the boiling point of an aldehyde lower? You'll notice, right? I've now turned this into a chem bonding question. It is everywhere. Can't escape. How do we compare two compounds? Remember, chem bonding of like simple molecules. What's the very first factor to discuss? You compare their IMF, yes, okay. But what's the factor that we look at? Electron cloud size. Okay, very good. Always compare the electron cloud size first. Now, can we do that in this case? You'll see, I'm purposely using a 2-carbon alcohol. It becomes a 2-carbon aldehyde. Just one look, you don't really need to do much. Is the electron cloud size similar or different? Roughly similar, right? How do I know that? Carbons, 2 carbons. Oxygen only at 1. Pretty much all around the same. So we can't compare electron cloud size. What's the secondary factor that we can relegate to? What can we move towards? We can now compare the type. The types of intermolecular forces are like ID, PD, hydrogen bonds, right? So we have to use this now because we can't compare the size. They are very similar in size anyway. How? Okay, so why? Aldehyde, what's the type of intermolecular force? Good. Stare at the structure. Aldehyde is PD attractions. Why? Why is it not hydrogen bonds? Okay, why aldehyde cannot undergo hydrogen bonding? It's very important because a lot of people tell me hydrogen bonds. Huge mistake. That's why in the next chapter on carbonyls, aldehydes, I will discuss structure and bonding because it's that important. Okay, take a look. The O is not bonded to the H, right? How can you form hydrogen bonds that way? Okay, O is not bonded to a H, so you can only do PD. How about the alcohol? What interaction? Now over here you can see O bonded to a H, so here is hydrogen bonds. You list down the interactions for each one of them, then what do we do now? We can simply compare. Can you see that? We can compare. So in other words, we know that PD is weaker than hydrogen bonds. So what next? Do we end off there? Or do we do next? Less energy. Guys, we have done enough chem bonding questions for the sake of our life. We've done enough already. Okay, but I still feel that a lot of people don't know how to compare. What's the process of taking out the factors? See, they can test anything. Okay, that's one example. Okay, so that ends my discussion on controlled oxidation. This is the part you need to spend most time studying. Okay, the rest of the oxidation I can go through within like 5 seconds. It's really normal. Okay, any questions so far? Okay, all good. Okay, I only went through the first part. Now, this second part, guys, do you think I need to control anything? No, right? It ends here anyway, right? So whack lah, right? Okay, it doesn't matter what you use. Okay, this is just called further oxidation. And for further oxidation, do I only need to use? Can I only use chromate? No, use whatever you want. You want to use dichromate? You want to use KMnO4? I don't care. It's up to you. KHUSO4, yes. Guys, do you need to heat with immediate nonsense? No. Okay, just heat under reflux. Now, guys, a lot of questions regarding this. Heat and heat under reflux, pretty much the same thing. But again, some teachers may be a bit strict. They might want you to write heat under reflux. So let me just explain what the hell is heat under reflux. A reflux is short for a reflux condenser. It's just an apparatus. It's a physical object. Heat under reflux means you heat for a damn long period of time. You constantly heat it. It's the direct opposite of immediately distilling the thing out, right? Okay, so the idea is you have to understand now, guys, organic reactions take hours. So you need to keep heating, heat under reflux. Okay, what it does is this, guys. You heat already, right? Sometimes the thing will turn into gas because you heat long enough, it will turn into gas, right? You heat for hours, confirm turn into gas. But when it turns into gas, what are you going to do? Let the gas fly away? No, you're going to lose everything. So the reflux allows you to condense it back into a liquid and then it repeats. Heat, turn into gas, condense. Heat, turn into gas, condense. Heat until the whole thing finished. So that's what heat under reflux is. Can see that so far? No questions? Can I? All right, secondary alcohols is our next focus. Guys, secondary alcohol can oxidize? Does it have a H on this carbon? Have H, It's invisible. Yeah, you can reflux everything. The short for that is called heat. Yeah. It's just your writing, whatever you want to write. Yeah, referring to the same thing. Yes.
It's the same thing.
Yeah, it's the same thing. If you're lazy to write heat under reflux, okay, or you can just write heat. Okay, if you're really scared, just write heat under reflux for everything, honestly. Yeah, okay, if you're concerned with that. And this has never been an issue in terms of like, maybe like one teacher I've come across damn anal about this. But other than that, no one really cares. Yeah, okay, but anyways, secondary alcohol turns into ketone. I told you all to recognize this earlier on in the lesson already. Okay, guys, that carbon, does it have a H? Does he have a H still? No. So it stops here. Do you need to control anything? No, just whack whatever you want. See, I'm done. It's the same exact shit as this. Very simple. Okay, so majority of the time, see whether you all can revise your primary alcohol. Okay, now next, tertiary alcohol can oxidize. Why not? That dude over there has no H. Finish. Less things to study. Hurry. Okay. Well, I'm done. Okay, that's for oxidation. Okay, if there are no questions, right, we can turn over to page 22. And as mentioned, guys, we are over here at this last reaction. Iodoform test is a subset of oxidation. That's why it's under the same section. And guys, okay, let's take a look. Our iodoform test. Yeah, I just need to mention one thing. In exam, if they ask you what's the type of reaction, can you all say iodoform test? What must you say instead? Okay, just write oxidation. Okay, in exam, what's the type of reaction? Do not ever write iodoform test, because that's not a legit reaction type. Okay, write oxidation. But anyways, some of the less important things we're gonna get out of the way first. You add I2NaOH and warm, but I need you all to know what's the purpose of this reaction. This is a very specific reaction. It's to test whether a compound has this particular functional group in red. I'm highlighting this in red. It's also in the notes. In short, we call this a methyl alcohol. Why methyl? Because there's a methyl group. You must have CH3OH and H. Then it is a successful iodoform test. The notes will have examples, so I'm going to give you guys examples now. I need you all to try. Okay? I'm going to draw the first structure, and I need you all to tell me, can this guy undergo iodoform test or not? Slowly go and see. And see fulfill the three things. Okay, so the carbon is over here, right? It's bonded to the OH. Here's OH. Does he have H? Have also, right? It's invisible. Does he have CH3? No, don't have. Okay, as you can see, two carbons, but it has to be one carbon. Anyone not sure about this? This is out. Let's look at a positive example instead. Can or cannot? Okay, can this guy undergo a successful iodoform test? Can? Okay, check out. The carbon of interest is the one bonded to the OH. Does he have OH? Yes. Does he have H? Yes, it's invisible. Does he have CH3? Yes. The CH3 is here. So as long as you have this portion, yes, good. Next. Can or cannot? Okay, can or cannot? No, right? Because over here, what is he missing? There's no CH3 again. Okay, this is like two freaking carbons. No, I do not want that. Okay, you have to keep drawing examples until you can see it. Okay. Can or cannot? Okay, slowly up. Does he have OH? Obviously. Does he have H? Yes. Does he have CH3? Yes. So can. Guys, you notice it's all these three guys fulfilled can already. Hey, but guys, what's the last item on that carbon? Wait, what's that last item there? It's like H. But isn't it like R here? Then you'll tell me must be R what? No, actually can be H as well. This is an exception. This is ethanol. It is an exception, right? In which you don't need to have an R, one H, okay also. You see the notes? They say R can be H, alkyl, or aryl. Aryl just means benzene. Can be H also, just take note. Not just alkyl group. Guys, ask you a simple question. You look at this requirement here. Is the alcohol primary, secondary, or tertiary? Okay, secondary, right? Because alkyl group, mostly is alkyl group and CH3. So methyl alcohol, take note, guys, is usually a secondary alcohol. However, ethanol is the exception. It is the only primary alcohol. The only primary alcohol that can undergo iodoform tests. Can see that? Hello? That's it. Now, unfortunately, right, we need to balance this equation. Okay, I tell you, if I tell you don't need to balance, means don't need. Okay, but it's not need. Okay, it has come out a few times. So unfortunately, we need to know how to balance this. So let me show you. I'm just going to draw this guy. This guy can obviously undergo iodoform test. Now, pay attention. Don't just look at it as a long ass equation. I want you all to look at the organic product first. Guys, take a look at the organic product. The organic product in this case looks like that. You don't even know how this is formed. Iodoform test, the mechanisms our syllabus. Okay, but take a look at this. How does this happen? Okay, or more or less, sorry, my question is, what is this functional group? It's similar to a carboxylic acid, right? But it is not a carboxylic acid because don't have H. This is the carboxylate salt. Why is it a carboxylate salt? Why is it not a carboxylic acid? Why not? What's this? Basic conditions, right? Basic conditions, obviously you're going to get a salt instead. And you notice something, guys. I have 3 carbons here, but now I only have 2 carbons. What is this reaction called? It is a step-down reaction. Now take note, iodoform test is a very classic step-down reaction. But before iodoform test, we have actually learned another one which allows you to decrease carbons. What is it? Oxidative cleavage. Good, because you're cutting the structure, right? When you cut something, right, obviously your number of carbons must decrease. So far, we have learned these two, okay? Mostly it's iodoform test. Again, the moment you see the carbon drop, right, high chance it could be one of these two reactions. Okay? But then where did the other carbon go? It can't just disappear, right? Guys, take a look. The other carbon became CHI3. Okay? The other carbon is CHI3, and you must be careful. Don't give me CH3I. It is CHI3. This guy, his name is iodoform. And he has a yellow precipitate. He is a yellow precipitate. This is the visual indicator for the test. It's a test after all for this functional group. You see yellow means good, you have a methyl alcohol. Now, whatever that I wrote here in blue are the organic items. These are the most important. If you end up forgetting the overall equation, I don't blame you, as long as you remember what are the organic products. You forget and forget, I can understand why. But I will not be able to see why you will not know the products of this. Very important. One of the most prevalent reactions in elucidation, legit. In fact, I can guarantee 99% of elucidation questions have one iron form test. Okay, because it's such a good way to see methyl alcohols. Okay, anyways, everything that's not blue color in purple is going to be the non-organic products. Just make a guess. I add I2, I add NaOH. So obviously, I add I2, I add OH minus, right? What does I2 become? Guys, after all, this is an oxidation. If there's oxidation, there's bound to be reduction. I2 reduced to I minus. OH minus just becomes water. Now, I'm not asking you all to memorize the whole thing. You all notice you can come up with this yourself. There's no need for memory work. You just need to know the organic products. The non-organic products are just copy-paste from the reagents and conditions. What you need to memorize, however, is this 4-digit number called 4655. It's for all the inorganic products. 4655. For organic products, nothing. Okay, so I'm not asking you all to memorize the whole thing. In fact, it's just memorizing the coefficients. I've made your life easier this way. I don't know how I remember 4655 also. Since I learned this for the first time in school last time, I can still remember this. Okay, so hopefully you all can remember this as well. Okay. I'll go through a little bit of phenols, then we can end off for today's lesson. Okay, very good. Anyways, any questions for isoform test? Yes, you will always, as long as you are able to undergo this, like for these two guys, you will produce CHI. 100% certain. Okay. Okay, I'll talk a little bit about phenols now. It's kind of running out of time. Okay, the reason why I want to talk about phenols now is I know it's a good time to stop here because we finished alcohol, right? It's because our next lesson is going to be a bit tight. I want to spend more time on elucidation if possible. Okay, so I'll try to cover more content in today's lesson first. Okay, for phenols, I want you to look back at these 6 reactions and we're going to see what can carry over to phenols. Okay, a phenol looks like this. Literally, it's a benzene with a OH bonded to it. Okay, I tell you all first, it can undergo redox and condensation still, yes. But the rest all cannot. We very quickly understand why. They will not test why cannot for most of them. Okay, but it's good to know also. First one, nucleosub. This one they can test. If you cannot undergo nucleosub, that means this bond can break or not. You can't break the bond because it is very strong. Can you remember why it's very strong? When you're bonded directly onto benzene, what's the concept behind it? Okay, got all the pi electron called delocalization, right? But the bond is very strong because of partial double bond character. I'll go over that again later, don't worry. Okay, I've gone through once in halogen derivatives. I'll go over another time over here. By now, I should be a lot more familiar. Okay, so it cannot undergo nucleosub because of partial. Yeah, I'll go over this. The partial double bond character. Guys, why can't you undergo dehydration? Dehydration means you remove water. OH and H. Now the H must be beside, right? So look at beside. Why can't you remove this H? Guys, you remove the H, what will happen to the ring on the benzene? The ring will die, right? It will break. And you do not want to break it because benzene has resonance stability. In other words, simple English, is benzene super stable. Circle cannot break on. So obviously the H is not going to break also, right? So let's say very quickly right now, cannot remove H as benzene has resonance stability. So we just very quickly understand why it cannot undergo all these other reactions. In a way, right, I am using this as as a method to kind of look back at what we just did earlier. Okay, guys. Why cannot oxidize? Come, it's not very easy. Why cannot oxidize? In order to oxidize, the carbon must have what? This carbon must have H, right? Does it have H? No, there's only an OH here, so out lah. Last one, can it undergo iodoform test? What does it not have? No metal, obviously. Where got metal? So you know all this out lah. The only one they will test is the first one. Why nucleosub cannot undergo for phenols? Okay, and we'll go over this. Okay, so erase because it's not part of the list. But guys, you notice yes, you can undergo the first two. But how about the benzene rate? You see one big fat benzene over there. What can it undergo? Benzenes undergo what? Benzene rich or poor? Rich, right? Rich must attack what? Which is what's okay? Poor is electrophilic, right? So it's electro what? Benzene very special, it's electro sub. So phenol, instead of 6 reactions, can only undergo 3. So technically, your starting here should be a lot easier. Half your work. Now, I want to explain 2 things. I'll explain the what do you call it? I'll explain why you cannot undergo nucleosub, and then we'll talk about reaction 1. Then we finish. Okay, reaction 1 very fast anyway. Okay. Okay, I'll explain the full package. Okay, on the next page, page 24, you can already see a box. Draw whatever I'm going to draw right now in the box. It's a diagram. Recap, guys. All the carbon atoms. What hybridization? sp2. If they are all sp2 hybridized, means they also all have a unhybridized p orbital. Okay, if all of them have a p orbital, let's draw this in a p, all of them. What would they do? Just stand there. What would they do since they're all side by side? They will overlap. Okay, but the keyword here is they will overlap continuously. So everyone join together. This creates a what? The electrons can now, what's that thing called? Delocalize. So this creates your delocalized high electron cloud. Hey guys, this is not the answer yet. I am just recapping the idea of benzene. If they ask you why benzene why have resonance stability, give me all this. Okay, I've run through this flow too many times to count already. Okay. But the expansion over here is this, the OH. O, what does it have also? O also has a p orbital, right? What would this p orbital do? It's literally right beside a carbon with a p orbital, so they can also overlap. Now that he has joined in the benzene overlap, right? What can the lone pair on oxygen do? What does it do now? All overlapping. So now the lone pair can delocalize into the benzene. Let's write that first. So your explanation for this part, p orbital must overlap first, then can delocalize. P orbital of oxygen overlaps with the high electron cloud of benzene. Don't just go straight to delocalize. I know too many people just like, oh, delocalize, but how, right? Okay, so lone pair of electrons on oxygen can delocalize into benzene. Again, highlight keywords. Your idea revolves around these keywords. Overlap, delocalize. What's next? I say I haven't explained why you cannot break that damn bond, right? Because now what happens to this bond? This bond now has partial double bond character, right? Okay, what's partial double bond? CO is a single bond, but it is no ordinary single bond. It has the strength of a double bond, but it's not actually a double bond. Okay, you can see that it's like a mix of single and double. So it has partial double bond character. But most importantly, you must highlight its strength, which makes it stronger and harder to break. Does it make sense? Okay, that's the idea. Highlight all these things. We've done this twice already. One in halogen derivatives, one in phenols. Content question in exam, if this comes out, need to get the mark. Because these kind of marks are easier to get than application. Application damn hard to get. You just haven't seen it. Like the stupid mechanism I asked you to draw just now. That's application. There's 2 marks. This has 2 marks. You tell me which one is easier to get, right? Okay. Right. Okay, any questions? If there are no questions, I want you guys to quickly go over to page 26, if I'm not wrong. I think my notes are a bit different. Okay, can you find the section that says redox? We'll cover that. Okay, copy finish first. When the news still have queued up to the order, yeah, go after this. What do I shift? Shift up. Also 1 week. Oh wow, if you go Japan, bloody hell. In law school, I'm not in law school, I cannot go Japan. What's going on? No, she has 1 exam. After she come back from Japan, I'm like, bro, I don't want to go. Okay, I came back from there. I also want to go travel. Yeah. Okay, anyways, any questions here? No, huh? Let's talk about redox very fast. It's a very easy reaction. I discussed that just now already. I'm just going to bring back alcohol. Alcohol react with sodium, give you your salt plus hydrogen gas. Half a hydrogen gas, by the way. You take a phenol, nothing's really going to change. You take a phenol, you react with sodium, you're still going to get the same shit. Okay, I only have 2 questions to ask you guys, and then we are done already. Okay, but however, we have a phenol reacting with NaOH now. Never really see this shit before, but suddenly come out one. You still get the salt and you still get hydrogen gas. Acid plus base give you salt plus water, obvious. Okay, all these are really easy. Okay, but what I'm concerned with is, oh yeah, before that. Okay, you all can call this guy the phenoxide ion. So it's just his name, huh? Okay, and there are also phenol, then phenoxide ion. So it's called alcohol, it's called alkoxide. I tell you all first so that in exam when you all see, you don't just go like, what the hell is this term? You know. Okay, now then I ask you 2 questions and then we are finished with this. First question. Okay, first question. Look at phenol. We are done with alcohol already. Look at phenol first. If you were to conduct a distinguishing test, do you add sodium hydroxide, or doesn't matter? Sorry? Okay, if I repeat, if let's say you were to conduct a distinguishing test, do you use sodium hydroxide, or doesn't matter? You can use either. Okay, so guys, a distinguishing test, you must be able to see something happening, right? Which one has a visible observation? Any, right? Because you produce this, what do you see? Effervescence. Don't go and choose this. I know the reaction is successful, but you don't see water and there's no observation. Everything just happens, it's invisible. Okay, so guys, let's take note. This guy here for sodium, use it as a distinguishing test. First question, finish. Very easy. Second question, guys. Okay, how do I? Okay, you're right now first. Okay, I want you all to infer something. Alcohol just now only react with sodium. Now suddenly phenol can react with not only sodium but sodium hydroxide. What does this imply? You notice I keep using the word acid, right? So I mentioned alcohols and phenols, yes, they can act as acids. I'll cover that next lesson. Okay, and this last question is a very good time to end because it will transition into acidity next lesson. Guys, take a look. Alcohol and phenol are both acids. But phenol can react with two things, alcohol can react with one. What does that mean? Phenol is a stronger acid. Yeah. Write this down. From what you can see from this data set, phenol can react with more items. So phenol is a stronger acid than alcohol. I want you to know this first, know this in advance, so that you know what to expect soon. Now I tell you all this, we're going to explain why next lesson. Okay? Yeah. Okay. Phenol is a stronger acid. The reason why they're acids, by the way, is because they have H for you to dissociate into H plus. For your info now. Okay, they're acids because you can dissociate this H to H plus. And with that ends off for today. Next lesson we'll answer acidity. That's probably the most important part. I don't know how your school teach, maybe they really screw it up. Okay, so I have to really touch on this soon. Okay, other than that, yeah, I will continue with the other two reactions next lesson, also quite important. And most of our stuff is tutorial. Any questions? Okay, if you don't have, remember before next lesson, I really need you all to go and look through all the reactions again. If not, the tutorial is just gonna end up sitting there, shit, I forget everything. Yeah, okay, at least read before the next lesson. Okay, and well, if that's